Hi, this is Mick Elliott from Electronic Specifier. I am on the Coilcraft stand at European Microwave Week with Flavio Sestagalli. And Flavio is going to talk us through a couple of products that Coilcraft have introduced at the show. And first of all, we're going to talk about some wire-wound inductors. Flavio, maybe if you could take us through some of the features.
Thank you so much. Thank you for this chance presenting our new series. First of all, I would like to introduce you our smallest wire-wound chip inductor. It's in 0402 metric, so a mere 0.4 by 0.2 millimeter footprint, and the height is just 0.28. So what's the peculiarity of this series? Actually, being the smallest, it still have a really very high Q, exceptional IQ. Just to give you an idea, the Q is in the range of the 30s for 900 megahertz and in the range of the 40s for a frequency of 2.4 gigahertz. You have quite a large variety of inductance values from 0.45 nanohenry up to 36 nanohenry. And another peculiarity of this series, which is named 016008C, is that they have also very low DCR. So as we said, the exceptional IQ compared to the closest competition in this size, which is a thin film technology, will be higher than 40%. What that brings? Actually, the IQ is very important to reduce the insertion loss in the RF antenna impedance matching, which makes these parts really small and ideal in cellular phone, wearable devices, LTE, IoT, 5G, so all the new technology which are, let's say, coming nowadays. Let me also show you a specific chart. Here you go. This is a comparison at different inductance values, and you see the closest part in the same form factor. They have time 10 DCR, and also it has lower DCR respect all the typical 02 or 01 thin film, which is the next size up. So this is really a brilliant product from Coilcraft, and it's already available as a standard product, included the design kits.
And this is your first metric inductor, yeah?
In this size, yes.
Yeah.
That's the worldwide smallest form factor wire-wound coil.
And it's available from Coilcraft or through distribution channel as well?
Yes, as well. Everything is already available on coilcraft.com. Free samples, designer kit as well for engineer. They can require anytime, so they are ready to go actually. Something that I forgot to mention before, the tolerance is quite interesting because it's quite tight. It's 5% tolerance on most of the inductance values, which is quite interesting in a so small form factor coil.
Okay, and I think you've got tools on your website to help designers make the right selection. Is that correct?
Yes, correct. There is a selection tool, so you can visit coilcraft.com. This selection tool, it gives you also the chance to select the highest Q coils for impedance matching by the frequency you operate, and then you have the possibility to select or let's say reduce the selection depending on the size you want to see, if you have size restriction, and then narrowing your selection down to the little ones or the smallest one by the Q at frequency you want to see.
Okay, and I also mentioned some ferrite beads, so would you like to tell us about those?
Yes, that's the second product I want to talk today. Just let me put a picture for you. Here you go. Those wire-wound ferrite beads are the second product I want to talk to you today. It's something interesting to use in EMI filtering. What's the peculiarity and the feature of these products? Actually, here you go. They have optimized impedance performance over a really wide range of frequency, much higher current handling than the standard technology on the market, which is multi-layer Ferrite beads. And so higher current handling, lower DCR, and another point is that they do not saturate. There is no core saturation close to the higher current rating, which is really giving them, let's say, extra possibility in using one of these versus many of the others connected in line. Let me show also another feature. Just this chart here. You see two curves. The red curves is related to the wire wound coil, and the black curve is related to the multi-layer Ferrite bead. Actually, what you see from here, those are both same size, 0402. The black line for a Ferrite is a part with the lowest DCR, and you see that at 100 megahertz the impedance starts dropping, while the wire wound one it's still let's say ramping up. So if you consider the long range of frequency, you will have a much wider impedance over frequency than the standard Ferrite bead. And okay, you can't read this number; they are really very small. But believe me, we can guarantee almost 1 ampere current rating versus 0.6 600 milliampere of the equivalent Ferrite bead. So more current, lower DCR, wider impedance over frequency.
What is the frequency range?
Well, actually, they go over 1 gig to 3 gig, 3 gig. So it's quite extended, yes. And another one, if we consider, because of Ferrite bead there are quite a large variety available. Mm-hmm. If we check the highest DCR Ferrite bead, same form factor, you see that more or less the two curves are the same. Yeah. So same high frequency attenuation. The differences here would be again very much into the number here, yeah, related to the current. Again, almost 1 ampere current handling versus 200 milliampere. So 5 times higher. And the DCR will be just, let's say, 0.09 ohm versus 1.3 ohm. So that's really interesting. And you have the same behavior of impedance over the wide range of impedance. So that's quite interesting product because you don't find just one size, but we have a variety of sides from the very small 0201 sides. You pass through the standard industry 0402, 0603, 0805, 1008 till the big one 1812. So you have really many different families to cover all the needs, depending on what impedance value you would need at your frequency.
And similarly with these products, there's design help on the Coilcraft website, tools and things to help selection.
Yes. That gives me a chance to introduce our tool. Okay. Thank you so much for this assist. Well, exactly. The big point, user or an engineer, myself as well, when I have a customer asking, okay, what I should use, actually this tool on coilcraft.com is exactly here for this. Actually, frequency, bandwidth eventually, impedance required, minimum impedance, current and DCR, clicking find. It's really very fast and direct. It gives you a list of possible suitable solution by different sides, and of course it gives you the charts. Yeah. So the graph we have seen in the previous slide, that would help you to judge if that is exactly the part you want. There is also something else, the tab analyze and compare. Maybe you know already a part, and you want to know, or you want to simply compare to something else, so you just go straight to that tab and you get immediately the chart. Charts are impedance versus frequency and inductance versus frequency. These are the two main charts you use to judge if this part would be suitable. Those parts are, again, just to reinforce the message, off the shelf.
Yeah. Okay. And the applications are?
Filtering, EMI filtering. Yeah. EMI filtering, even in power application. So whenever you complete your design and you have some issues in emission, you sometimes start to add a lot of multi-layer chip beads in line, trying to cover the widest frequency range possible. Sometimes one of these products is just fair enough, smaller and covering wider range and with more efficiency, as we said, higher current handling and lower DCR. This is really the beauty of this kind of technology wire wand.
Okay. Flavio Sestagalli from Coilcraft, thank you very much.
Thank you so much.